In this example, we're going to look at a multi-stage financial calculation problem. So we have here that Aaron plans to retire at age 65 and estimates that $46,800 a year in retirement for 27 years is going to be needed. To save for retirement, Aaron plans to put money every month into a 401k plan at work. If Aaron is currently 26, how much will need to be saved each month to meet the retirement goal, assuming the retirement account earns an average of 6.1% per year? Notice that because we're putting money into the account monthly, that automatically tells us that interest is going to compound monthly as well. So those have to match. So keep that in mind as we move forward. The first thing we're going to do here is kind of draw a picture to see what's going on. We have here that Aaron is age 26 right now, and he's going to retire at the age of 65. So what we see here is that 65 minus 26 represents 39 years of savings and inflation, if we were to take that into account. But 39 years of savings is the most important part here. And then also we know that he wants to take out $46,800 per year, and he wants to do that for 27 years. So that will take him to age 92. Now, again, keep in mind that we're told that he's going to take out $46,800 per year, but he's going to be pulling stuff out monthly. So essentially, it comes out to be a $3,900 monthly withdrawal, and you can get that simply by taking the annual amount and dividing by 12. And again, I know that these are monthly withdrawals because we're told that he's going to be putting money in every month, and so we're going to assume that's how he's going to withdraw them as well. It also tells us how often the interest is going to compound, both before and after retirement. So that's sort of the picture, and what we have to do is figure out if we want this over here, this monthly withdrawal every month for 27 years, we're going to need to have some amount of money at this point where he retires. So that's kind of our first step. We need to know what needs to be in the account at this time, at the age of retirement. Once we know that, then we can go backwards 39 years and figure out what the contribution should be in order to get to that big lump sum amount that will be in the retirement account at the age of retirement. So that's the strategy. So we're going to make note that the interest rate is 6.1% per year. We are not told that that changes, so we can make the assumption that that is true both when he's making the contributions and when he's in retirement. So that's our goal. Let's find that monthly contribution. So let's take a look at this picture here. And again, what we're going to do here is figure out what is the principal that needs to be in the account at the age of retirement if you're going to make withdrawals W. So we have this formula from our formula sheet, and we know what the withdrawal is going to be, $3,900. We know the rate of return, 6.1%. We know that there are 12 compoundings per year, and we know how long we're going to take those withdrawals out. How many years? It's 27 years. So then we're going to take that amount, this principal P, which is the amount that needs to be in the retirement account, and we're going to say, oh, well, that needs to be the amount A that is required, or actually that needs to be the amount A that we need in the account, and it'll allow us to solve for the deposits D, a D that we're going to put into the account. So basically, this principal amount P is going to be the amount A that needs to be in the account associated with deposits D. So there's two different equations at play here. That's the strategy. So when we do the first calculation, we get this result. Plugging in all the numbers, we get a principal at the age of retirement of $618,809.36. So if that's the amount in the account at the age of retirement, then Aaron will be able to take out the $46,800 per year in monthly withdrawals for a total of 27 years, and that $618,000 or so will be completely depleted. So that's what has to be in the account. Now, we need to understand that the next step is to ask the question, if we need that amount of money in the account, then how much should he be investing monthly before he retires? So the deposit D that he needs in order to have the amount capital A in the account is given with this formula here that we've seen prior in the course. So the deposit is going to be equal to the amount that's in the account times the interest rate, and then all of the other numbers you can see filled in down here as well. Keep in mind that this is going to take place for 39 years because he's making contributions for 39 years. So between the age of 26 and 65, there's 39 years worth of contributions. And so we have to make sure we get that number correct. And when we do that, we get $323.32. So to be able to pull out $46,800 a year, Aaron is going to need to deposit $323.32 every month between the age 26 and 65. If he does that, when he retires at age 65, he'll have $618,809.36, and that will generate $46,800 a year in his retirement for a total of 27 years.